Okay, here's 529. So Lacey and Richens each have a personal function machine. Lacey's machine, L of X, squares the input and then subtracts 1. Richens' function adds 2 to the input and then multiplies by 3, write the equations. So you already got the equations, right? And then they decide to connect their two machines so that Lacey's output becomes Richens' input. You better give me the two equations. What are my two equations?
L of X equals X squared minus 1, and then R of X equals 3 times X plus 2. Yeah.
Is the X plus 2 in parentheses or not?
Yeah.
Yeah? Does everybody agree with these two?
Mm-hmm.
Okay, so I have those, and I'm trying to connect her output becomes his input. So that means I kind of have to plug this in to there. Does that make sense at all to anybody? Because whatever X that you put in, you want to do this to it first. You want to square it and subtract 1 before you stick it in there. So what I'm going to do is algebraically, I'm just going to make some room inside his little function machine thing. See how I made an empty space where that X is? And I'm going to substitute in X squared minus 1 for that X. I'll put it in little extra parentheses. Hopefully that doesn't make it look too weird. Does that make, are you guys okay with that? That's just her function. So this is actually, what is this? This is R of L of X, if you want to give it a special notation. Okay, and then you can fix it up inside there. You can say, well, that's negative 1 plus 2, so that's X squared plus 1. So, was that all they wanted for letter B? If 3 is the initial input, what's the output? So stick a 3 in there. So, R of L of 3, that's a little notation you can use for it. So that's going to be 3 times, well, 3 squared is 9 plus 1, so that's going to be 3 times 10. Did anyone get 30?
Yeah.
Okay. So there's that, and that's the notation that you can use for that kind of stuff. And then for letter C, what is the order of what if the order of the machines is changed? Would it change the output? Justify your answer. So you can justify it by just maybe doing it again over here. Or does anyone have a justification that is so good that you don't have to do the number?
What you could do is you could just write the answer that you get is not equal to 30. So if you want to get your answer, you can say, I got 224 is not equal to 30.
I want to do the whole thing backwards. I know, that's crazy. So now this time I'm going to stick this whole thing, the R function, into the L function. So the L function has something squared minus 1, right? But the R function, I'm going to stick it in there where the X was. So I'm going to go 3 times X plus 2. And I won't do all the notation, the fancy notation. I'll just real quick do it. So if I plug the 30 in here, or no, what does it say? What if the order would it change the output? So just plug the 3 back in and see. So 3 plus 2 is 6, and 6 times 3 is 18, and 18 squared is... Oh, wait, what? 3 plus 2 is 5. Sorry. 3 plus 2 is 5 times 3 is 15. 15 squared, I think, is 225 minus 1 is 224. So I got 224. So I didn't get the same answer, did I? So it turns out that the order does matter, doesn't it? Can you guys buy that? Do you see what a drastic difference it made? I didn't show all my work on this side, but I just did the same procedure. Is that okay? Alright, how do I do